All right, we are now going to go into the 12.1 notes. So this gives us a quick overview of what we learned in chapter 3. Chapter 3, we learned about bivariate data and their relationship using regression. We can use sample regression lines to estimate the true population regression line. So the true population regression line is U sub y equals alpha plus beta x. All right, so let's go over what this stuff means. So mu y is the predicted mean of y hat. Alpha is the population y-intercept. And beta is the slope of the population. So all right, now on your reference sheet, you have these originals, y hat equals a plus bx. And then b naught plus b1 x. And that's for like a different test. Okay, so we want to determine if there's a linear relationship using the slope. Okay, that's what this is about. So conditions for regression, and we usually just check these with the graph, pretty straightforward. So first condition is that it must be linear. So the relationship between x and y needs to be linear, and you can figure this out using a scatter plot or a residual plot. Okay, next they need to be independent. So individual observations are independent of each other, and if there's not replacement, then you have to use a 10% rule. All right, normal. So the response variable y, sorry, let me just fix up the screen here a little bit. Okay, let's brighten that up a bit for you. Okay, hopefully that's a bit better. All right, so the response variable y varies according to a normal distribution. Okay, now, equal variance. So the standard deviation of y needs to be the same as the standard deviation for x. So the standard deviation for y needs to be the same as x. So you can check a residual plot for similar scatter there. Okay, last one, random. The data needs to come from a well-designed random sample or experiment given, in the problem. Okay. So regression lines don't go through all the points on the scatter plot. If they do, it's like clearly correlated. Like there's not really a question if it's a straight line. So there's variability. A residual is what calculates that variance. So the equation for a residual is the observed minus the expected. And this is y minus y hat. I like to use predicted. That's probably what you'll hear me saying when I bring this up again. Observed minus predicted, observed minus expected, y minus y hat. Okay, so the standard deviation of all of the residuals can be found by taking the square root of the sum of all of these residuals squared divided by n minus 2. Okay, next we have the standard error of the slope. So standard error of the slope, that's what this little sub b is for. Okay, this is the standard deviation of the residuals divided by, this is the standard deviation of the values, the input values, the x's, times root n minus 1. All right. So to calculate a confidence interval for a slope, our degrees of freedom are n minus 2. So we take our slope and we add or subtract our t star, our critical t value, times the standard error of the slope. And remember, to do this, you would just use inverse t of, so say we wanted a 95% confidence level, keep in mind, if that's 95%, we want to use everything to the left, which would be 0.975. And then whatever that degrees of freedom would be. So area under the curve, degrees of freedom. Okay, so let's go ahead and do an example where we construct a confidence interval. So this problem is not quite complete. It didn't quite, it's bleh, sorry, good talking here. So this is for 10 helicopter rides. And we really need to know that because otherwise we don't know n and we can't find our degrees of freedom here. Okay, so using the fact that this is for 10 helicopter rides, let's go ahead and create this confidence interval. So let's go through and identify everything here. So the constant is going to be our y-intercept. And so it would be alpha if we're using the fancy one. I'm just going to use a and b because same idea. So my y-intercept is a, my slope is b. And let's see, now this right here is the standard error of b, or the standard error of the slope. Okay, we can find some other stuff here. For example, this is the standard deviation of residuals. This is r squared. You could find r by taking the square root of r squared. So what we really need to find here, though, is we know b, we need to find t star and the standard error of b. So first thing let's find here is our degrees. Well, let's do our degrees of freedom first. So our degrees of freedom, we have 10 helicopter rides minus 2. So I have 8 degrees of freedom. Now we're doing a 95% confidence interval. So to find my t star, I'm going to do t inverse with 0.975, comma 8. And I'm going to type that into my calculator. And I get 0.2306. All right, so we got my t star, and I got my degrees of freedom here. So now I'm going to go ahead and write out my formula. All right, so I got mu y, it's alpha plus beta y. So let's go ahead and plug stuff in. So alpha is going to correspond to A. which is going to be negative 0.03761, plus beta is going to correspond to B, 0.0057244. All right, and now to find my confidence interval, I'm going to take my slope here, or my confidence interval on the slope. That's really what we're finding. I take 0.0057244 plus or minus, and now I'm going to throw on my t star, 0.2306 plus or minus, no wait, just times. Okay, times the standard deviation of B, which we know the equation for, and it comes out to be 0.000, wow, I'm on a roll, folks. So it's right here, 0.0002018. Okay, so let's go ahead and do this. All right, so I get a confidence interval of 0.0057 to 0.0058. Let me definitely, sorry, I'm just making sure I didn't mess up anywhere, guys. There we go, sorry. I got the wrong T star. I wrote the decimal in the wrong place. 2.3, and that completely changes my answer here, so. Let me try that one more time. All right, there we go. I'm like, that doesn't seem quite right to me. All right, so this comes out to be, I'll just do it in black right over the top, 0.0053, ranging up to 0.0062. And that would be my confidence interval of the slope. So we're 95% confident that the true slope of the population lies between 0.0053 and 0.0062. Okay. In the next video, we will talk about significance testing.